Waterberg FM. Go with the flow.
Good morning, listeners, and more especially to our learners. Today it is mathematics, grade 11. We are continuing with our last week's lesson on analytical geometry. And then we're still going to use the same sketch that we used last week. So if you are having the sketch, bring it along. If you don't, bring a pencil, a piece of paper which is having a Cartesian plane or a set of axes, a calculator, and a ruler. And then we're going to capture our sketch afresh so that we can all follow on what we are doing. And then today we are going to look more into the angle of inclination and the angles which are related to our geometric figure. We'll also be looking at the area and the perimeter of a figure. We will also explore on the unknown point which will be transforming our figure into another figure. So let us quickly capture our sketch. On a set of axes, we are going to locate our points. We're having a point we called P with coordinates 1, 1. Meaning the x value at P is 1, the corresponding y value is 1. The second point, point Q, with coordinates 0, -2. The x value at Q is 0, and the corresponding y value is -2. Our third point was point R. Last week was an unknown point, but we found the coordinates of R, and there were 6, -4. Okay, and then now we're going to join our points to have a geometric figure, which is a triangle. And then it is triangle PQ is equals to -x plus 2, and the line QR was defined by x plus 3y plus 6 equals to 0. And then we have calculated the equation. We determined the equation of line PQ, and we found that it is y is equals to 3x minus 2. Okay, so today we are going to be looking more into points, and then the angle R. Two more points on our sketch. The x-intercept of line PQ. Let us call the x-intercept of line PQ, call it point M. And then we are going to call the x-intercept of line PR point N. Okay, when we look at the two lines, line PQ and line PR, they are intersecting the x-axis. So we are going to calculate the angles of inclination of those two lines. And then the angles of inclinations of those two lines, they are also going to help us to find angle theta. So for better reference, we are going to talk about the angle of inclination of line PQ. We are going to refer to that line as angle alpha. Remember, I said that the angle of inclination, when a line intersects the x-axis, we have the left-hand side of that line and the right-hand side of that line. So the angle which you refer to as the angle of inclination, it is the angle that we measure from the right-hand side of the line, the 0 degrees moving anti-clockwise. And then we call line PQ. I move to the right-hand side of that line from the x-axis, which we also refer to as the positive x-axis, moving anti-clockwise to touch line PQ. Let us call or refer to that angle that is formed as angle alpha. And then the angle of inclination which is formed by line. The reason why I am calling the two angles alpha and beta, there's nothing special, it's just for the simple or easier reference. But note that angle alpha and angle beta were not given from the original sketch. So if you are going to name or refer to a particular angle as alpha or beta, be sure to go to your sketch and indicate the angle that you refer as alpha or the angle that you refer as beta. So I went to my sketch, I've shown the angle that I refer to as alpha and the angle that I refer to as beta. So you do the same with your sketch. If you're going to refer to those angles with any name, be sure to show on your sketch. Okay, so when we find the angles of inclination, I said last week that there are two angles that we get when we move from the 0 degrees to the line of reference. The first angle, it is what we call the angle of inclination, which is the angle we measure from the 0 degrees anti-clockwise to the line. That angle, it is what you call the angle of inclination. And then there is another line that we get moving from 0 degrees to the line in a clockwise direction. And then that angle, it is a supplementary angle to the angle of inclination to form a straight line. In our first case, we are talking of the line PQ. So the first angle which we have, which is angle of inclination, we refer to as alpha. And then there is another angle that is formed when we move from 0 degrees to the line in an anti-clockwise direction. The relationship between the two is that they are supplementary angles, meaning when we add them, they give us 180 degrees. And then another thing, when you calculate the angle of inclination, you must always have the expectations. What is it that you expect from your line? The angle of inclination, it is angle between 0 and 180 degrees. And then when we find the angle of inclination of a increasing function or a line with a positive gradient, we get a positive angle when we relate the tan of an angle with the gradient of that particular line. The reason being that the angle that is formed, our angle of inclination, it is an acute angle. And when we find the angle of inclination from a decreasing function, our angle, we find a negative angle. Negative acute, meaning that is our supplementary angle to the angle of inclination. The reason is that whenever you do the tan inverse of the gradient, you're going to get an acute angle. And acute angle can be a positive acute or a negative acute. So when we do the line which is a decreasing function, we get a negative angle because the acute angle, it is the angle that is measured in the clockwise direction. So always have those expectations in mind, so that whenever you find the results which are not making sense, you can go back and check, because when we do calculations, there is always a room for errors. You can easily make mistakes, but then at least you can minimize your errors by knowing what is it that you are expecting. So the first angle, we are going to calculate angle alpha, and then the relationship between angle alpha and our gradient of PQ is that the tan of angle alpha is equals to the gradient of line PQ, because we form angle alpha by moving from the positive x-axis to line PQ, and we have calculated the gradient of PQ as positive 3. So finding alpha, we are making alpha by taking the tan inverse of the gradient, which is positive 3. And then it is going to give us the tan inverse of 3. You punch in your calculator, tan inverse of positive 3. It's going to give us 71.757 degrees. So that is our angle alpha, because you note that what we have there, it is a positive acute. So alpha, it is measured from 0 degrees in an anti-clockwise direction, which is in the positive angle. So we have found our angle alpha there. The next angle of inclination is angle beta, which is angle of inclination of line PR. So we are going to take the tan of angle beta will be equals to the gradient of line PR, because for us to form beta, we have moved from 0 degrees to the line PR, and the gradient of PR, we got it as -1 from the definition of the line, the equation of the line, which was given as y is equals to -x plus 2. So to get beta, we are going to make beta the subject by taking the tan inverse of the gradient of the line, which is -1. You punch in your calculator tan inverse of -1, it is giving us -45 degrees. Now, for us to get beta, or beta, when we calculate it, our expectations were that beta is a positive angle, and it is positive obtuse angle. So what we get there is a negative acute. So meaning that what we got there, it is not beta, but the supplementary angle to beta to form the straight line, angle on a straight line of PR. So we refer to this now as the ref angle, or the supplementary angle to the angle of inclination. So our beta, to get beta, we just go and less 45 from 180 degrees. We less 45, not -45, because the negative, it is telling us about the direction in which we travel. So when we want the angle beta, its magnitude, we just less the magnitude of the ref angle from 180, which is going to give us 135 degrees. So our angle alpha is an acute angle, which is 71.57, and beta is 135 degrees. Those are the angles of inclination of line PQ and PR respectively. So the question as it came, it requested that you find angle theta. And angle theta, we can't get it straight by relating it to the angle of inclination, because angle theta is not formed by a line with the x-axis, but it is formed by two lines. So it means we need the link from the angle of inclination or angles of inclination to angle theta. So that link, we note that it is angle P. Angle P, it is in the triangle PMN, and it is also in triangle PQR. So if we can find angle P from the small triangle, we can move to the bigger triangle to find angle theta. So when you look at the smaller triangle PMN, angle beta now becomes the exterior angle to that smaller triangle. And then now you bring in your properties of triangles. You know that the exterior angle of a triangle is equals to the sum of interior opposite angles, meaning that angle beta is equals to angle P plus angle alpha. Your reason for saying this is that angle beta is the exterior angle of a triangle. But then we have calculated angle beta, we have calculated angle alpha, so we can find angle P by subtracting alpha from beta. Our beta we said is 135 degrees, and then we subtract 71.57 degrees, and then it is going to give us the size of angle P. So our angle P, 135, when you subtract 71.57, it gives us 63.43 degrees. So that is the size of angle P. Last week when we were checking the relationship of the lines, we discovered that the line PQ is perpendicular to line QR, meaning that the angle that is formed when the two lines intersect, which is angle Q, is equals to 90 degrees. And then now we have just found that angle P is 63.43 degrees. And then again, you recall the property of a triangle, that the sum of interior angles of a triangle equals to 180 degrees. So if we take angle Q plus angle P plus angle R, it is going to give us 180 degrees, because it is the sum of interior angles of a triangle. So we are having two angles, angle Q, we have angle P, we can find angle R, which is what we were requested to find initially as angle theta. So I substitute my Q as 90 degrees, I substitute my P as 63.43 degrees, and then my R is theta is equals to 180 degrees. So to get theta, I am going to less 90 and 63 from 180 degrees, which gives me that theta is 26.57 degrees. So I have calculated all the angles which are relating to my figure now. Now, you would note that angle theta is actually angle which is between PR and QR. So another person could have decided, instead of moving from the smaller triangle, decided to use the line QR. So if you wanted to use line QR, it means you were supposed to extend that line up until it intersects with the x-axis, because as it is, QR was not intersecting, but then if we continue with the same pattern, it is going to intersect the x-axis at some point, and then it will form an angle there, which will be the angle of inclination. And then if you check from the x-intercept of line QR, the x-intercept of line PR, and then to R, you have a triangle there, which now you can find the two angles which are formed with the x-axis, and then it will help you to find angle R. So we're not going to do that. You can try it yourself, but then at the end of the day, angle theta is 26.57. So even if you use a different angle, you must arrive at the same solution. Okay, now the next thing that we are going to look at, it is the area of quadrilateral QMNR. We are going to look at the quadrilateral QMNR. So how do we calculate the area of that triangle, of that quadrilateral? Now, if you look at that quadrilateral, it is actually an irregular quadrilateral. So when we have an irregular quadrilateral, you can find its area by either dividing your quadrilateral into triangles, or like if you look at that, the quadrilateral QMNR is coming from triangle PQR. So if I less that smaller triangle, I am remaining with a quadrilateral QMNR. So I can find the area of that quadrilateral by finding the area of the bigger triangle, which is triangle PQR, and then lessing the smaller triangle or subtracting the smaller triangle. Then I will be remaining with the area of the quadrilateral QMNR. It is irregular, but we can find its area by relating it to the familiar polygons which we know. And then in this case, it is the difference between the two triangles. So we are going to calculate the area firstly of the bigger triangle, which is triangle PQR. So if we find the area of that triangle, we know from grade 8 and 9 that the area of triangle PQR is given by half of the base multiply the perpendicular height. So if we take our QR as the base, it means that PQ will be our perpendicular height. And then last week we found the length of PQ as the square root of 10. Now it means we need to calculate the length of QR, which is going to be the length of QR will be the square root of x at Q, which is 0, minus x at R, which is 6 squared, plus y at Q, which is negative 2, minus y at R, which is negative 4 squared. So we have 0 minus 6 is negative 6 squared, that will be 36, plus negative 2 minus negative 4, that will be positive 2 squared, that is 4. So we are having length of QR as the square root of 40 units, or you can write it in simplified sub form as 2 the square root of 10. So we are having our base and our perpendicular height. So you go and make substitutions there. The area of triangle PQR is equals to half of PQ multiply QR, which is your perpendicular height. So when I substitute, I have half of the square root of 10 multiply 2 the square root of 10. And then you calculate there, it's going to give you the area of triangle PQR as 10 square units. That is the area of triangle PQR. And then we are going to less the area of PMN from the area of PQR to remain with the area of the quadrilateral QMNR. So we are going to calculate the area of triangle PMN. And then when you look at triangle PMN, it's not a right angled triangle. So if you don't have a right angled triangle, it means now you have to make use of the 3D area rule, which we have there, which is given by the sides. We're having side PM multiply PN, and then the sine of the angle in between them, which will be angle P. And then we do not have the two sides which we need to use, which is P and M. So for us to get that, it means firstly we need to find the coordinates of M and N. Quickly, we know M, it is the x-intercept of PQ, which means we're going to go to our formula, to the equation of PQ, where we see y, we substitute by 0. So it means that the corresponding y value, x value for that, we have 0 is equals to 3x minus 2, meaning x is equals to 2 over 3. So it means the coordinates of M will be 2 over 3 corresponding to 0. So the x value at M is 2 over 3 and the corresponding y value is 0. And then when we check the coordinates of N, N is the x-intercept of PR. It means we go to the equation of PR where we see y, we put 0 is equals to negative x plus 2. And then the x value there will be positive 2. So it means the coordinates of N, we have 2, 0. So those are the two x-intercepts of our lines. And then finding line PM, I am going to take the distance formula, the square root of x at P, which is 1, minus x at M, which is 2 over 3 squared, plus the y value at P, which is 1, minus y value at M, which is 0 squared. So the length of PM will be 1 minus 2 over 3, which is 1 over 3 squared. That will be 1 over 9, plus 1 minus 0. 1 minus 0 squared is 1. The square root of that gives us the square root of 10 over 9 units, which is the length of PM. And then we calculate the second line that we need, which is PN. The length of PN, the same formula, the square root of x at P, which is 1, minus x at N, which is 2 squared, plus y at P, 1 minus y at N, which is 0 squared. So it's going to give us 1 minus 2 squared is 1, plus 1 minus 0 squared is also 1. So we have the length of Pn as the square root of 2 units. Now we can find the area of triangle PMN, because we say that the area of triangle PMN using the area rule is equals to half of PM multiply Pn sine of P. Making our substitutions, we have PM, we said PM is the square root of 10 over 9 multiply Pn, which is the square root of 2, and then the sine of angle P. We found angle P as 63,43 degrees. And then we make our calculations. You go to your calculator, you have 1 over 2 multiply the square root of 10 divided by 9, and then multiply the square root of 2 multiply sine of 63,43, which is giving us 0,67 square units. So now we can find the area of quadrilateral QMNR. So the area of quadrilateral QMNR will be the area of triangle PQR minus the area of triangle PMN. So when we find the difference there, it will give us the area of our quadrilateral. It is irregular, but we can use the polygons which you know to find its area. You just put in those areas and then it will give you the area of that quadrilateral. So I am not going to make substitutions because of time. I wanted us now to look at the transformation that will change our triangle into a quadrilateral. We have a point somewhere in our Cartesian plane, point S, and point S is in such a way that PQRS is a parallelogram. So for us to find the coordinates of S, it means we need to go back to grade 9 and recall the properties of a parallelogram. We have 3 properties of a parallelogram. The first one says that the opposite angles of a parallelogram are equal. The second one, we have the both pairs of opposite sides of a parallelogram are equal and parallel. And the third property, the diagonals of a parallelogram bisect each other. So to find point S, you can use any of those properties. You can use the opposite sides of a parallelogram. It means you're going to find, if you use equal, the sides which are equal, you have PQ equals to SR, and then you have PS equals to QS. So you are going to formulate 2 equations because you'll be having 2 unknown variables there. The x value at S and the the y value at S. So there are 2 unknown variables. It means you will need 2 equations to solve for those. Or if you use the gradients, you're going to make use of the knowledge that the parallel lines, remember they tell you that the gradients of the lines are equal. So that means that the gradient of PQ, which is 3, will be equals to the gradient of QR. And then the gradient of QR will be equals to the gradient of PS. So again, you have 2 unknown variables, you need 2 equations. And then the other one which I am going to use, it is the knowledge that the diagonals of our parallelogram are bisecting each other. So by bisecting each other, we say that they share a midpoint, meaning the midpoint of PR is the same as the midpoint of QS. So we are going to firstly calculate the midpoint of PR, which is the x value at that midpoint will be x value at P, which is 1, plus x value at R, which is 6, divided by 2, and the corresponding y value y at P plus y at R, meaning we have 1 plus -4 divided by 2. So this shows us that the midpoint of PR, which is a diagonal, is 7 over 2, and the corresponding y value is -3 over 2. So those are the coordinates of the midpoint of PR, which is the same as the midpoint of QS. So we are going to find the midpoint of QS using the coordinate at Q and S, and then equating them to what we already know here. So if we take x value at Q, which is 0, plus x value at S divided by 2, it will be equal to the x value at midpoint, which already found as 7 over 2. And the corresponding y value at Q, which is -2, if we add y value at S divided by 2, is going to be equals to -3 over 2, because we say that the diagonals of a parallelogram bisect each other. So we're having 2 equations, 2 unknown variables we solve for the value of x and y value. So from the first equation that we have, x at S is going to be +7, because we have the same denominators there, and then I have 0 plus x at S is equals to 7, meaning that x at S will be 7. And then the corresponding y value, I have the same denominators, meaning -2 plus y at S is equals to -3. To make y at S the subject, I am going to take -2 to the right hand side with its additive inverse, which will give me -1, because -2, when it moves to the right hand side, it will be +2. So I have -3 plus 2, which gives me -1, meaning that the coordinates of S will be 7, -1. All right. Now we are having a parallelogram PQRS, and then we have all the coordinates that we need. Now, I always encourage learners to interrogate their sketches or to analyze what they are having against what they discover. We are told that PQRS is a parallelogram, hence we used that knowledge to find the coordinates of S. But again, you can go a step further and make some conclusions. Like we said that one of the properties of parallelogram is that the opposite angles are equal. So that means that if angle Q is 90 degrees, it means even angle S is 90 degrees, because now we have the opposite angles of a parallelogram. So if angle Q is 90 degrees, angle S is 90 degrees. We can make a conclusion again to say that it means that our quadrilateral PQRS, which is a parallelogram, it is a special type of a parallelogram which we call a rectangle. And then again, we can make further conclusions. The reason why we say it's a rectangle, it is because the angles, the corner angles equals to 90 degrees. And then another conclusion that we can make from this sketch is that PQRS, it is a cyclic quadrilateral. The reason why we make this conclusion is because we know that one of the properties of a cyclic quadrilateral is that the opposite angles are supplementary. Now, when I look my opposite angles here, I have angle Q and angle S. I said that angle Q is 90 degrees. We have found that by determining that the two lines are perpendicular, and then angle S is also 90 degrees because there are opposite angles of a parallelogram. But then when I add 90 plus 90, I have 180 degrees. So that tells me that PQRS is a cyclic quadrilateral. The reason why you need to keep on doing this is that some learners, they only think that a cyclic quadrilateral is identified by the corners of a quadrilateral being at the circumference of a circle. But then the properties of a quadrilateral are the ones which make it cyclic. More like if you are talking of a graduate, we don't say someone is a graduate because they are wearing their academic regalia. If you wear your academic regalia, if you take it off, that doesn't mean that you cease to be a graduate. So the same thing with our cyclic quadrilateral. That circle, it is just a regalia, or it is just a clothing. So the properties are the ones which will tell you that this is a cyclic quadrilateral. So that is how far we were able to go with our lesson. I thank you.